Hello. First, in analyzing purchasing department costs and its respective cost drivers, I first analyzed the data and I identified two discrepancies. So the first was that the Sheridan observation included the state of Wyoming, so I just removed that right here into just Sheridan. And then for the Salt Lake City observation, the correct value was 2,506, and the input value was 206 for the number of purchase orders. And so I included the 2,506 correct amount for all of my regression analyses. Um, and this is in my memo, but after performing the regression analysis and finding these statistics, I identified the best model to be the number of purchase orders and the number of suppliers as the two independent variables or cost drivers in the model. And this is because it offers the highest adjusted R squared. I didn't want to rely solely on R squared to indicate a causal relationship because this only increases if you add another independent variable, even if the variable is irrelevant to your model. So that's how I kind of wanted to differentiate this model, which combines all three, from this model, which only combines these two cost drivers. And these simple regression analysis models for each cost driver offered some benefit from looking at, but I identified the best one of these to be the number of purchase orders model. The worst one was merchandise purchase. As you can see, this has a very low R squared and adjusted R squared, and then the T statistics and P values are not where they should be, as I stated here. But yeah, this is the best simple regression model. Still not the best though, because it doesn't give us the best R squared or adjusted R squared as our multiple regression analysis models do. But I noted this in my memo that if we have a multiple regression model and one of the independent variables or cost drivers has a t statistic that is below or above 2, we want to include it in our model. But if it's below 2, then this should usually be removed. And we can kind of see that here, and given the fact that this regression analysis shows very little causal relationship between merchandise purchase and purchasing department costs, I just chose this as the best model because it omits that variable, because it kind of shows us that it's irrelevant, because the T statistic and P values aren't what they should be. The standard error for that was also extremely high. And the standard error here, even compared to our model that includes all three variables, the standard error is the lowest here. But moving on, I just input simple regression models on Power BI. I didn't want to do multiple regression on here. It's too complicated. But yeah, this just shows very little correlation between merchandise purchase and purchasing department costs. This is the best simple regression model, as I stated, and then number of suppliers is the second best. But I chose to just use multiple regression on RStudio because it's easier. But I just wanted to verify my data, and I got the same R squared and adjusted R squared for this model, and then we can see the plot here, which shows pretty good correlation for these variables. But this is for all three variables or all cost drivers that were included in the model. I just wanted to verify my results. So that's kind of the regression analysis that I went through. But as for the recommendations for Dan's Western Wear, I recommended that let me pull this up. Given this model here, they should decrease the number of purchase orders that customers place, as well as the number of suppliers they use. Quantitatively, for decreasing the number of purchase orders, there will be, of course, less cost, which is the goal, purchasing department costs, and there will just be less qualitatively. There will be less input that the staff will have to go through for each of these orders. and there will just be less labor intensive work overall, which I outlined in my memo. But then in decreasing the number of suppliers, which was my second recommendation, um, it's pretty similar to decreasing the number of purchase orders. There will be less, I guess, maintenance or like upkeep from the purchasing department staff, since there will be less suppliers. Um, and there will be less maintenance of relationships, I would say, for just supplier relationships in general. But one downside of this, though, is you're relying on less vendors or suppliers. Um, and so the company would have to make sure that the suppliers they do use are trustworthy and reliable, and that they can provide all of the products necessary and in a timely manner as well. For decreasing the number of purchase orders as well, Dan's Western Wear will, or they could offer discounts to employees that customers that buy in bulk. Um, and this may seem a little counterintuitive because you're attempting to decrease costs, but in the process, you're offering customers discounts. But I think the difference between these two would be very great, and the discounts offered would also enhance customer relationships too. They might be incentivized to buy more product in general. So I do think it could increase profits and also, in the process, decrease purchasing department costs. Um, but both of these have very, very similar ramifications, I would say, for Dan's Western Wear. But I think overall they could just help increase purchasing department efficiency, and lower um, upkeep and maintenance from the staff. They won't have to place as many orders, they won't have to maintain as many supplier relationships, and they'll just have more time to allocate to researching suppliers or just maintaining records in general, but they won't have to have as much upkeep, and therefore there won't be as many costs associated with maintaining as many records from purchase orders or from supplier like maintenance agreements. Um, so yeah, those are my recommendations, and I hope you enjoyed my regression analysis.